Hi everyone, welcome back. This is our last video of section 6.3, okay, and it's going to be about solving exponential equations, okay, or solving equations that have exponents in them. But first, I want to introduce an important number that we're going to see for the rest of the course, and that you'll see throughout the rest of your mathematical career, and that's the number e. So e, like pi, is a special number, okay, and it's a number that has an infinite number of decimal points, and it just keeps on going. Okay? E can be defined in many ways, and I put this here, but it's not important. What you need to remember, most of all, is that e is just a number. It's a special number, but e is really 2.718, and then the decimals keep on going. Okay, but it's just a number, like pi, right? But it has a special meaning, or it comes up a lot for exponential equations and logarithms, which we'll see next time. Okay, so that's e. And so often you'll see exponential equations where the base is e instead of base whatever. Right, so here's an example. Again, we've done plenty of these in the last video, so I'm actually not going to go over it. But you can think through, as an extra practice, for graphing exponential equations. Okay, think through what you would do, find the domain, range, and horizontal asymptote. Okay? But we're going to move on to solving exponential equations. So, exponential equations are equations that involve terms of the form a raised to the x power, where a is positive and it's not equal 1. Those are there because if it was negative, that's no good. And if it was 1, that's no fun, because everything is 1 when you have a base of 1. Okay? So anyway, equations can be solved by applying the different laws of exponents. Okay? And so one law of exponent, or the law of exponents, says that if I have a raised to the u power, a raised to some power, and that's equal to a raised to another power, okay, then it must be true that the exponents are equal. Okay? Meaning that if I have 2 raised to the third power, and that's equal to 2 raised to the x power, it must be true then that x is 3. That's the only way that can happen. The only way that they're equal is if x is equal to 3. All right? And so we're going to use that here to our advantage. So if we look at our example here, I'm going to rewrite it just for my own sanity and quirkiness. We've got 3 raised to the x plus 1 power is equal to 81. Okay? And so this problem is not yet in the form of which we can use it. And what I mean by that is that both don't have base 3. Okay? So they need to have the same base in order to apply this law of exponents that we're going to use. And so I need to change either 3 or 81 to be in terms of the other, or to get the same base, is what I'm trying to say. And it turns out that we will always want to change the larger number into the smaller number. Okay? Or we might have to decrease both. But anyway, in this case, we're going to have to turn 81 into 3 raised to the whatever power. Okay, so we need 3x plus 1 is equal to, hopefully, 3 raised to some power. But now we have to think, 3 raised to what power is 81? Okay, and I know this might be hard for you, but I know you can do it. 3 squared is 9. Clearly not it. 3 cubed, 3 times 3 is 9, times 3 is 27. so 3 cubed is 27, but 3 to the 4th power is 81. And so it's true here that I can rewrite 81 as 3 to the 4th power. And now I can use my law of exponents above to say that if this is true, then x plus 1 must equal 4, which means that x must equal 3 if I subtract 1 on both sides. Hence, I've solved the exponential equation. Okay, so let's do it now with the second example here. 4 raised to the 2x minus 1 power equals 8 raised to the x plus 3 power. Now, it is true that 8 is equal to 4 times 2, but I can't think of terms in multiplication. I need to think of everything in terms of power, okay? Some number raised to the something. And that's not necessarily equal to multiplication. And so it turns out that I can't have a smaller number raised, I can't have a base of 4, because 4 raised to whatever power is not equal to 8. Okay, I can't get 4 to the 8th power. There's no a, at least that we're working with, that's a whole number, that will get this right. Okay, so I can't simplify it with base 4, but what I do know is that 4, I could rewrite 4 as 2 squared. So instead of 4 raised to the 2x minus 1, I could have 2 squared raised to the 2x minus 1. And it turns out that 8 is really 2 cubed. So it's really 2 cubed raised to the x plus 3th power. And now I can use another one of my laws of exponents. I have something raised to the something power, and then that whole thing is raised to another power. We know that the exponents will multiply in this situation. And so I get 2 raised to the 4x minus 2th power, okay, equals 2 raised to the 3x plus 9 power. Because I have the same base, it must be true that the exponents are equal, so I set them equal. And I get, when I subtract 3x and add 2, that x is equal to 11. Okay, so we need to change the base first, change so we get like bases, then get rid of the bases, and then just do some algebra. Okay, same base, get rid of the bases, simplify. 3 steps, that's all you need to do. Simplifying might take a couple of steps, and getting rid of the base might take 1 or 2 steps. But that's the general form. Okay. So let's do 2 more quick examples, and then we'll finish off with a your turn. Okay. So here I have e raised to the negative x quantity squared, or e raised to the negative x squared. Okay, not quantity squared. Equals e raised to the x quantity squared times 1 over e cubed. Okay, so I have base e almost everywhere, but it's not quite in the form that we want it. Something else that I should note is that I can't have something like 2 to the x plus 3 equals 2 to the y power. I can't simplify that and get rid of the bases when there's anything other than just that equals that. Okay, whenever there's a plus 3 in here, or really anything in here, that's, if it's not of the form 2 to the x is equal to 2 to the y, I can't get rid of the bases. Okay, only true when it is this exact form, where of course you could have other numbers than 2 and other things in the exponent other than x and y, but hopefully you know what I mean there. So anyway, that's important to keep in mind. We've got all base e's, okay, but it's not quite in the form that we want it. And so we have e raised to the negative x squared power, okay, equals, the 2 cannot come down because it isn't e raised to the x quantity squared. Okay, there is a difference there. But I can use that law on this part. I get e to the 2x, okay? The squared comes down inside and becomes part of the exponent, okay? And then on the right side, I've got 1 over e cubed. And if you remember way back to the beginning of this section, I talked about a number of laws of exponents. And it turns out that 1 over e cubed can be written as e to the negative third power. So if I have a number raised to some positive power in the bottom of a fraction, I can change the sign on the number, and that moves the whole expression into the numerator. Okay? So now I've got e raised to the negative x squared equals e to the 2x times e to the negative third. I can then use another law of exponent right here and get e to the 2x minus 3. Again, I need to combine so there's only one thing on the right and one thing on the left before I can use that law of exponent, the other law of exponent that I showed in the previous slide. Okay, but when I have the same base, I multiply things together, the exponents add. Okay, and so now I can get rid of the bases and have negative x squared equals 2x minus 3. I need 2, this is a quadratic type of thing, so I need to get everything over on one side, have the other side equal to 0, and then solve. And so to do that, I'm going to add x squared to both sides. And I get 0 is equal to x squared plus 2x minus 3. Okay? And then I need to factor that side and solve like I have been the whole class. And so this is not a bad problem. It's x and x. They need to add to 2, multiply to negative 3. And so I think that's pretty clear that it's plus 3 and minus 1. And so the solutions are x is equal to negative 3 from this part, and, x is equal to 1. And so those are the solutions. Okay? And then last, we have a quicker example here. 16 is 2 raised to the 4th power. And so I have 2 raised to the negative x power is equal to 2 raised to the 4th power. That means negative x is equal to 4, or x is equal to negative 4. Okay, so that wasn't a hard one there. Now, here are 2 examples. Okay, solve those equations using the laws of exponents that we've been working on.